Welcome to the Art of Strength and Mind podcast with your hosts, Brandon Duff and Eugene Trufkin.
This is a podcast about healthy living.
Okay, so I'd like to welcome to our podcast today, Dr. Hoffman. Today we're going to talk about interface theory. Not many people are kind of like familiar with that theory. So can you kind of tell our audience a description about your work with that theory and kind of like what it encompasses?
Okay, most of us think that when we look around and see objects like the sun, the moon, stars, tables, chairs, and so forth, we're seeing reality pretty much as it is. And most of us believe that because whenever we look, say, at this table, we see the table, we look away, and then when we look back, we still see the same table. And everybody else looks and they say a table and so forth. And so we assume that we're all seeing the same true world. Not exhaustively. None of us believes that we see all of the truth, but we believe that we do see truly what's there in reality. And I began to ask the question from the point of view of evolution by natural selection. Does evolution favor true perceptions? If our senses were shaped by natural selection, what is the probability that evolution would make our senses tell us the truth about the world? Again, not all the truth, but some truths about the world. And so I did evolutionary game simulations. It turns out that evolution by natural selection is a mathematically precise theory. So we can actually run simulations and we can even prove theorems. And what we found in the simulations was that organisms that see reality as it is are never more fit than organisms that see none of reality and are just tuned to relevant fitness payoffs. What that means is that evolution would drive the organisms that see the truth to extinction whenever they compete with organisms that don't see the truth and are just tuned to fitness payoffs. And then, given the simulations, we should try to prove a theorem, and we have, and it turns out it is a theorem of evolution by natural selection, that true perceptions, what vision scientists call veridical perceptions, are not favored by evolution. Instead, what evolution seems to favor are perceptions that hide the truth and that just give us like a user interface that lets us do what we need to do to control the truth without actually knowing the truth. So for example, if you're using your computer to make some graphics in a paint program, and you have a paintbrush icon, no one believes that there's actually a little paintbrush inside the computer. The icon on your desktop is just a little icon that you use to control the computer, but there's no paintbrush inside the computer. So the shape of the icon of the paintbrush doesn't mean that there's some shape like that in the computer. The position of the icon of the paintbrush, say it's in the middle of the screen, that doesn't mean there's a paintbrush in the middle of your computer. So the color of the icon isn't true. The shape of the icon isn't true. The position of the icon isn't true. And those are all of its properties. None of them are true. Nevertheless, the interface is very, very useful because what your interface on your desktop is doing is it's hiding all the complexity of the computer, the diodes, resistors, voltages, magnetic fields. It's hiding all that. If you had to like toggle voltages to paint an image, you'd just give up. You wouldn't do it. It'd just be crazy. So in fact, not knowing the truth is a help. That's a big surprise. Being forced to see the truth will get in your way. And so what evolution has done is it's completely hidden the truth from us. Whatever reality is, it's not space and time. It's not physical objects. It's something utterly different than anything that we perceive. Utterly different. Three-dimensional space, as you perceive it, is just your desktop. And physical objects are just super icons. They're not flat icons, they're three-dimensional icons. And pretty soon, by the way, we will have three-dimensional desktops on our computers. Well, the technology is there, and eventually we'll open up our laptops and there'll be icons in 3D that we can manipulate, and they'll be much more functional when they're three-dimensional. We can do stuff with them.
Well, we can do that now with like virtual reality, right?
Exactly right.
So you're saying that we currently live in a virtual reality.
That's right. This is really a virtual reality that we're immersed in. And evolution immersed us in a virtual reality that's unlike whatever the real reality is. And the point of this virtual reality, from an evolutionary point of view, is simply to guide adaptive actions. That is, to allow us to behave in ways that let us stay alive long enough to reproduce and raise kids. So the goal of evolution is to make you a grandparent, not to show you the truth.
So, what is the point of reproduction if it's all a simulation then?
From the point of view of evolution by natural selection, right, that reproduction is about passing genes to the next generation. And so it's all about, in some sense, from an evolutionary point of view, evolutionary biologists would say that the whole point is it's all about the genes. The genes boot up our bodies and our minds and our perceptual systems just as a fancy way to let the genes get into the next generation. So from an evolutionary point of view, and every evolutionary biologist would sort of take this point of view, that in some sense, it's really not so much about us, but about the genes getting into the next generation. But I think your question was deeper, not what do evolutionary biologists say today, but if we assume that this is not the truth, then what is it about? And I don't know. That's a really, so I can tell you what the evolutionary biologists think, but some of their basic assumptions I think are going to be false. They assume that physical objects in space-time exist even when no one looks. They assume that that's reality. But the evolution, the core of evolution, which is an algorithm, is sometimes called universal Darwinism. It's the algorithm of having variation, selection, and retention. We can use the same algorithm to evolve ideas. It's called memes. Lots of things. Scientific theories compete and die. So we have this evolutionary algorithm that works not just for biological systems, but for ideas, for scientific theories, for songs, and so forth. So it's that abstract core of evolution is what I used to prove that we don't see, space and time and physical objects are not showing us the truth. But that theory doesn't tell me what the truth is, right? So it's one thing to take evolution by natural selection and say that theory entails that this is all a virtual reality. It's not the truth. It's hiding whatever the truth is. Now it's another step to say, okay, well, what is that truth? That cannot be answered by evolution by natural selection. So I do have ideas about what reality might be, but I don't have any theorems to prove that I'm right about it. So I can say what my ideas are.
Yeah, we'd love to hear it.
Yeah, that'd be great.
So the thing that has motivated me to even study this work about evolution by natural selection and perception is the issue of consciousness. This is one of the interesting open questions in science. We know that various conscious experiences, like my experience of the color green, are highly correlated with certain activities of the brain. So, for example, if I see a green apple over here in the right part of the visual world, there's a high probability that I'll have cortical activity in something called area V4 of the brain in my left hemisphere. And if you take a magnet that can inhibit cortical activity, like transcranial magnetic stimulation, TMS, transcranial magnetic stimulation, you can use that to inhibit, you just touch it to a person's head. And the magnetic strength is so strong that it'll go through the skull and can actually inhibit the activity of the neurons in the brain below it. So the magnet is strong enough. It's the same strength that they use for picking up cars in junkyards.
Oh, wow.
It's a really strong magnet, but highly focused. So this is a dangerous magnet. You don't want to play with it.
Yeah.
You can fry your brain. But under careful circumstances, you can take that magnet, touch it to the skull next to area V4 of visual cortex, inhibit that area, and you will see all the color drain from the right half of your visual world.
Wow.
You see just black, shades of gray and black and white. You take the magnet away, and the color seeps back in. And then you can take the magnet and put it in an excite mode, and what you'll see are color phosphenes, all sort of psychedelic colors that flash in the right visual world if you touch it to the left hemisphere. If you touch it to the right hemisphere, then the same effects will happen in the left visual world. So we have examples like that, we have examples in motion perception. If you touch the magnet to an area called MT on the left hemisphere, you can make it so the person sees no motion at all in the right visual world. So it's more like just a stroboscope. I see you there, doing this, but I don't see your smooth motion in between. But in the left visual field, I see smooth motion.
Wow.
So I move my hand here, I see my hand moving smoothly, then all of a sudden it's pop, 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 pop. Then you take the magnet away and you get motion perception coming back smoothly. So these are just two of hundreds of very nice, strong correlations we have between neural activity and our conscious experiences. And so this obviously begs for scientific theory. What is the relationship between our conscious experiences of colors, motions, objects, and other senses, our moods, the sounds that we hear, the smells and tastes and so forth? What is the relationship between those conscious experiences as experiences and brain activity? And most of my colleagues in the neurosciences and cognitive neuroscience assume that brain activity somehow causes or creates our conscious experiences.
I mean, to give you a crazy, not a crazy experience, but I remember I was training a woman and she was gone for about a year, and I wasn't training her. It was a client of another trainer of ours. And I was like, where's she been? I haven't seen her in like a year. And then a couple hours later, she shows up out of nowhere and she's like, oh, I'm ready to train again. And I'm like, how does that happen? Like, how did I, out of just randomly, think about this woman, and then that same day she shows up out of nowhere?
Right, those are very interesting, coordinations of experiences. The issue here is it your brain somehow, activity in the brain that's actually causing these experiences, that's causing you to think this, causing you to experience this bottle of water, causing you to experience this table? Is it your brain activity that's doing it or not? We have hundreds of these kinds of correlations between neural activity and conscious experiences, like the ones I just talked about between color and area V4 and motion and area MT. So the question is, as scientists, we'd like to understand what's going on here. Does brain activity cause these conscious experiences? Does activity in area V4 somehow cause my experience of colors? Does activity in area MT of the brain somehow cause my experience of motion? And if so, precisely how? How does neural activity create the magic of a conscious experience? Because if you think about what is neural activity, put quite simply, it's various ions like sodium, potassium, and calcium ions shuttling back and forth through holes in neural membranes, and then certain neurotransmitters being emitted by presynaptic membranes and being absorbed by or locked into receptors in postsynaptic membranes. So how do you go from that description of brain activity at either the single cell level or systems of neurons doing that kind of thing, interacting that way? How do you go from that, without waving your hands and pulling rabbits out of the hat, to a description of my experience of the taste of chocolate or the smell of garlic or the sound of a trumpet? How do I go from neural activity to those real experienced conscious experiences? And that's been, it turns out, such a difficult problem that we call it the hard problem of consciousness, which means we don't have any really good ideas. It's not just that we don't have any decent theories, we have no plausible ideas about how to solve this problem. No one's figured out how to start with unconscious ingredients like neural activity and cook up consciousness. No one knows how to do it. That's one reason that hard problem was what got me going to ask myself, what kinds of assumptions are we making in the sciences, in cognitive neuroscience, that might be getting in the way of us solving this problem, this hard problem of consciousness? And that's when I began to look at evolution by natural selection and ask the question, does evolution favor perceptual systems that show us the truth? And the reason I ask that is when we assume that brain activity causes our conscious experiences, we're assuming that neurons in fact exist in reality, independent of whether we perceive them, and that neurons actually have causal powers, even if we don't perceive them. So we're assuming, in other words, that when we look through microscopes at brains and we see neurons, we're seeing the truth. And that was why I went after this question. Are we seeing the truth, or are we seeing just a virtual reality? And so that's when I found out the evolution by natural selection is saying, no, what you see in everyday life, when you see tables and chairs, and when you look through microscopes and see neurons, you're not seeing the truth. You're seeing a virtual reality. But there was no selection pressures for us to recognize that. Someone who thinks they're seeing the truth will do just as well having kids
Yeah.
as someone who is a geek and sits around. Well, maybe I don't see the truth. In fact, it might be not in your favor to be a geek and say I don't see the truth. It might be better to just say I see the truth and I'm going to act on it. But when we come to do science now, we're trying to understand how brain activity and conscious experiences are related. That assumption that we see the truth is now getting in the way. That's my claim. So neurons don't even exist when they're not perceived, because neurons, like every other object that we see, is an icon that we create in the act of observing. So I see this bottle of water. It's a data structure. I'm using computer science language. It's a data structure that I create to represent certain fitness payoffs that I might get. It tells me how to hold it. It tells me that I could drink this. It's not going to bite me. It's not going to slap me in the face. I learn a lot by this data structure. It's a very, very valuable data structure. It's just not the truth. It's simply a simple data structure that's telling me about fitness payoffs, what to expect, and how to get those fitness payoffs. But there is no such thing as a pre-existing bottle of water. So I look and I create this bottle of water as a data structure. I just garbage collected it. I threw it away because I'm saving memory. I don't need that structure. Now I need it. So I'm using it again. So neurons are the same thing. Neurons are data structures that we create when we look through microscopes at brains. So as soon as we look away, we garbage collect those neurons. They don't have any causal powers. If that's correct, then that means that the hard problem of consciousness is hard because we've made a false assumption. We assume that neurons exist independent of our observations, and we assume that neurons actually create our experiences and actually cause our behaviors and so forth. And I must say that for everyday neuroscience, that's perfectly fine. I talk that way all the time. I'll say that area V1 of cortex, the activity there causes area V2 activations because there's a projection, and V2 feeds back information to V1. It's perfectly fine to talk that way in everyday neuroscience. It's like if you're using a paint program, you can say, yeah, if you drag the paint program over here and get the color red and then drag it across, you'll get red. And you can talk as though the paint brush that you're seeing actually has real causal powers. It doesn't. I mean, but that's perfectly fine for the interface to make that assumption. If you're in Grand Theft Auto, you can talk about how you're driving the car and what you need to do. And within that game, that's a good description. But in fact, the car that you're seeing does nothing, right? It's actually circuits inside the computer that are doing all the work. All you're seeing are simple icons that are helping you just control that complexity. But in fact, the car does nothing. And the wheel that you're turning does nothing. Those are just simple, useful symbols for you. So in everyday neuroscience, it's perfectly fine for us to talk about brains and neurons as if they exist when they're not perceived, and it works. But we're only in the interface. As soon as we're trying to understand consciousness, now we're going under the hood. Now we're like a software designer who's not just playing the game, they want to build a game. And if you want to build a game, then you have to let go of the illusion that the car and the steering wheel in Grand Theft Auto really do anything. You have to be much more sophisticated and understand how the circuits are related to that car and the steering wheel and the real deeper causal relationships that go on there. So that's what I'm claiming is going on with this hard problem of consciousness. Everyday neuroscience, it's fine to say neurons cause our behaviors and cause other neurons to fire. For the hard problem of consciousness, now we have to be more sophisticated. We have to recognize that natural selection shaped us to see a virtual reality, not the truth, and that literally nothing we see has causal powers. It looks like my hand caused that bottle to move. For everyday descriptions, that's perfectly fine to assume that. And most of science does assume that. We assume that physical objects have causal powers. Newton does that and so forth. And that's perfectly fine. But in reality, it's a fiction. This is just a useful fiction that any physical object has any causal powers. So this rabbit hole goes pretty deep, right? As soon as you start asking, does natural selection favor true perceptions? And the answer is no. The rabbit hole goes very, very deep. It means even space and time, as we perceive them, aren't the truth. We make up space-time, and it's just like a desktop of your computer. It's just the desktop itself, and the objects that you see are just like the icons in that desktop. It's not the truth. Now, you can ask, well, okay, it's one thing for a cognitive scientist to be talking trash about space-time.
Well, what do like hardcore physicists say about, because isn't physics like just basically all about like space and time? Isn't that like the foundation
Right.
to all of
Physicists
physics?
would surely, you would think, surely the physicist will tell this cognitive scientist, that he's
Crazy.
barking up the wrong tree here. Well, it turns out that in the last few years, physicists have realized that space-time is doomed. And that's a quote, space-time is doomed. There's a professor of physics that I recommend named Nima, Nima, Arkani Hamed, Arkani-Hamed. Nima Arkani Hamed. He's at the Institute for Advanced Study at Princeton. And if you just Google his name and Space-Time is Doomed, you'll find some fairly accessible videos where he's describing why physicists now believe that they have to let go of space-time. Einstein thought it was fundamental. Most of us believe it's fundamental. It can't be. It turns out that to get general relativity and quantum theory to play well together, we're going to have to let go of space-time. In fact, it's even deeper than that. There's fundamental problems with general relativity and fundamental problems with quantum mechanics on their own terms. And so we're going to have to let go of space-time anyway to get a deeper theory that will allow us to then understand why general relativity and quantum theory do work as well as they do in the physics that we have today. So it's not like they're useless. They're very, very useful theories, but it's very much like knowing about how to drive a car in Grand Theft Auto is very useful in the interface, but it's not deep enough if you want to understand actually what's going on under the hood. And that's what the physicists are realizing. Space-time is just the desktop. They want to get under the hood, and they realize that there's something deeper under the hood, and they don't know what it is. Nima Arkani Hamed is playing with something he calls the amplitude-hedron, which is a geometric structure which actually can predict the behavior of particles in the Large Hadron Collider, the scattering amplitudes of these particles. It's quite striking that this mathematical structure, which is not in space and time, it's prior to space and time, it's deeper. And somehow space and time emerge from it. But this is a deeper reality. And when you do the computations in this deeper reality, the math gets simple. When you do it in space and time, it turns out the math is nasty. Hundreds of pages of algebra that you have to compute to see if these particles come in, which particles will go out, the so-called scattering amplitudes. When you go to this deeper reality, and they don't know what the deeper reality is, it goes down to one or two terms that you can compute by hand. Very, very straightforward. So nature is telling us that space-time is fine, but you haven't gone deep enough. There's something deeper. There's a deeper notion. So the physicists are now chasing after what that is. In this deeper reality, all the complicated stuff that you have to do in space and time, they have all these virtual particles that pop up and are created and annihilate each other, and you have to keep track of them, all these things called Feynman diagrams and so forth. It's quite a big mess, and that's why by keeping track of them, you have hundreds of pages of math that you have to do to actually compute what's going to happen when two particles collide. When you go into this deeper realm, all that difficulty disappears. You get simple computations. In fact, what they find is that the math comes down to simple, what they call permutations. Like if I take the numbers 1, 2, 3, 4, permute them 3, 4, 1, 2, 4, 3, 1, 2. Very, very simple stuff. That's the kind of math that you end up looking at, and they don't know why. They're trying to figure out what is that deeper reality that lets you have permutations as opposed to so-called unitary operators that are working in space-time quantum field theory, for example. So the physicists are saying that space-time is doomed. It's not just a cognitive scientist off taking too much drugs or something like that that's saying this. The physicists themselves are saying, look, our hard-nosed mathematical models are telling us that there's something deeper here, and we don't know what it is. They're very excited to find out what it is. But I think we're getting convergence, that all the physics we've been doing so far has really been just in the interface. It's all been in space and time. We've been doing good work. I wouldn't say we're playing. They've been doing really good work in the interface. And for the first time, physicists are now starting to say, what's behind the space-time interface? And it's scary because it's hard for us to think outside of space and time. Space-time has such a grip on our imagination. You might say, well, okay, if there's some geometric thing called the amplituhedron, where is it? Well, it's not in space and time. You can't talk about where it is in the same way you can talk about where this bottle is. And so it's prior to space and time. It's not somewhere. It's before the notion of somewhere even existed, which is, that's hard to wrap our minds around that, but that's where the physicists are going. So all this nasty math just comes down to permutations and simple geometry. When you go to this other realm, they don't know what it is. So what I'm proposing now, and again, I'm probably wrong, right? All scientific theories so far apparently have been wrong. Even our best ones, general relativity and quantum theory, are wrong. They're not trivially wrong. They have a lot that's going for them, but we now know that there's something deeply wrong, and we're trying to figure it out. So the chances that I'm right is pretty small. I'm no Einstein. So, but the idea of science is to be bold and precise so that you can then figure out where you're wrong. So I'll be bold and precise. So my proposal is we can't start with unconscious physical objects like neurons or protons and neutrons, electrons, and try to boot up consciousness. No one has any idea how to do that. And if evolution is true, then those things don't even exist except as interface descriptions. They're not the true source of causal power. So how am I going to solve the consciousness brain hard problem? Well, because I'm not very bright, I can only think about one direction. Maybe if I can't start with brains and boot up consciousness, maybe I'll start with consciousness and see if I can boot up the physical world and brains. So that's the direction I'm going. I'm saying, okay, let's assume instead of saying reality is space-time and matter and so forth, that's the fundamental reality. I'm going to say consciousness, my experience of the smell of garlic, my feeling of pain. These kinds of things are not latecomers in the universe. They're the foundation of the universe. They're the ultimate nature of reality. So what I call conscious agents, and I've published a paper, it's called Objects of Consciousness. So if you look up Objects of Consciousness and Donald Hoffman, you can find the paper, it's free online, where I have a mathematical model of consciousness, what I call conscious agents, where again, I'm being absolutely precise about what I think a conscious agent is. It has a set of experiences, conscious experiences that are real experiences. It makes decisions based on those about what actions it can take. And I describe mathematically how to model this. And so each conscious agent then has experiences, makes decisions, and takes actions. And my proposal is that the universe, not the space-time universe, but the deeper universe, is a vast social network of conscious agents. That's what's going on there. It's a huge social network of conscious agents, and it has a really interesting property. When two agents interact in the right way, when they interact in just the right way, two agents will create a new single agent. In fact, lots of agents interacting together in the right way can create a new single agent. So there's bottom-up process here where agents create higher level agents, but then the agent itself at the higher level that they create has its own decisions and actions, so that has a top-down influence as well. It's a novel top-down influence. So this is a non-trivial, it turns out mathematically this is a really complicated system. But it's very much like thinking about a Twitter network or Facebook, where it's a big social network of who's, say, tweeting and who's following whom, what ideas are trending and so forth. And if you were trying to understand, there's, I don't know how many hundreds of millions of people on Twitter and so forth, or Facebook. If you're trying to understand what's going on there, that's a lot. I mean, it's just overwhelming to think about understanding all that. So what you would like is perhaps a graphical visualization tool that you can use to say, well, what's trending in Irvine? What's happening in New York? And have a graphical visualization tool that says who's important, who's sort of a hub. Lots of people are following this person, and they're sending out lots of tweets and they're trending. And who's just a peripheral player. There's lots of things you might want. So you would love to have a graphical visualization tool. And that's what I claim our perception of space, time, and objects is. Evolution gave us just a graphical visualization tool that we use to navigate this vast social network of conscious agents. And that so I can use my graphical visualization tool to see what's happening in her brain, but then I can move through the network, go to Las Vegas, go to New York or San Francisco and so forth. And my tool will give me different insights into it. So right now, as I'm sitting with you, my visualization tool is giving me more detailed insights into two conscious agents, you and you. So those are the conscious agents that my tool is now giving me some insight. All I see in my tool is a face, hair, and skin. I don't actually see your conscious experiences, right? You can't see mine. But if you smile, then I assume that probably your experience is happy. And if you frown, then your experience might. So I have a portal, my visualization tool of space and time and physical objects, including your face and your bodies, which are just my icons that I'm creating. They're a little portal into your consciousness. But of course, you know that there's lots of about your consciousness that I have no idea. In fact, if you look at yourself in the mirror, all you see is your own face. You don't see your conscious experiences in the mirror, but you know that behind your face is the whole rich world of your conscious experiences, your fears, your dreams, your aspirations, your love of music, your love of weight training and so forth. All this stuff that's all there. I can't see it directly. I can only guess. So my interface gives me a small portal into your realm of consciousness and into your realm of consciousness. It's fallible. I could try to fool you, right? I could pretend to be happy if I'm feeling sad and so forth. So that's what's going on. Space and time, physical objects are a graphical visualization tool that we use to navigate a vast social network of conscious agents, which is the ultimate nature of reality, which is an interesting point of view. It's about the weirdest thing you could think about without taking drugs.
Were you the original founder of this theory or this idea of like, oh, you might not see reality for what it is, and I'm going to try to kind of like maybe objectively prove it one day?
I would say that this kind of idea has been around. So, for example, there's a very famous philosopher named George Berkeley. He was in England, and uh, several hundred years ago, I think in the 1700s, he had the idea that we don't see the truth, that all of these objects that we see are just ideas in our mind. He used the word, ideas. So what I'm saying is very similar to Berkeley, although it is different. He was assuming he was a bishop in the Church of England, and so he was coming this as a way to defend his Christianity. And so he wanted to defend Christianity against what he thought was the mechanism of Newton, even though Newton himself was a Christian. Pretty much everybody was. So he came up with the idea that we don't see reality as it is. These are just ideas in mind, but that they're real in another sense, that they're always in God's mind. His ideas are similar to mine, but I'm not talking about God, and I'm not saying that this exists even when I don't look at it because it's in God's mind. But the big difference between me and Berkeley is I'm doing it mathematically precise. I mean, I'm actually writing down a mathematical theory about this, whereas Berkeley was just words. Before Berkeley, there was a guy named Leibniz, a German genius, mathematician, philosopher, engineer, just one of the smartest men that ever walked the planet. And he had the idea as well. He understood this hard problem of consciousness that I was talking about. He actually understood very, very clearly that there was no way that you could boot up conscious experiences from mechanical systems. And he understood mechanical systems very well. He actually built a computer, compute up to 16 decimals, I think, or something like that, or 16 digits, which is pretty impressive for that time. Again, that's, I think in the 1700s or something like that. Yeah, so I wouldn't say that the idea that we don't see reality as it is at all new to me. Also, Immanuel Kant is very famous for saying that what he calls the phenomenal realm of our experience is different from the noumenal realm of objective reality. So my idea is not new. What's new, I guess, is for me to say I can show that this idea follows as a theorem from one of our best scientific theories, namely evolution by natural selection. That's one new contribution with me and my collaborators like Chetan Prakash and Manish Singh and Chris Fields and Robert Prentner, some of my colleagues. The other contribution is to say, well, okay, what is the nature of objective reality behind this? And Leibniz had a very similar idea to mine. He said, look, it's not space-time and objects. It's what he called monads. And monads were these these perceiving creatures. They were perceivers. So they weren't fundamentally physical entities. They were fundamentally perceivers. So in some sense, Leibniz monadology is very similar in spirit to what I'm proposing. But again, he didn't propose a mathematical model. And I would say right up front that, of course, my mathematical talents are minuscule compared to Leibniz's. If Leibniz were here today, he could run circles around me. My only advantage is I had several centuries of mathematical work that he didn't have access to. If Leibniz were here today, I would just be reading his papers and saying, yay, keep doing it, because he would run circles around me. But, he was born first and I'm born later, so I had the advantage of all that. So what's different about my work from Leibniz is that it's mathematically precise, that I'm saying, this is what I mean by conscious agent. And again, I'm probably wrong. If I had to bet, I would probably bet against myself. The point of science is to be absolutely precise and make a strong claim. So I'm claiming that my theory of consciousness leaves nothing out. There's no aspect of consciousness that my theory of conscious agents can leave out. So it's a really bold claim. The other bold claim is reality consists only of this vast social network of conscious agents and their interfaces, like space and time is the interface that we happen to use. Other consciousnesses that could be utterly unlike us would have experiences that we can't even imagine.
Are you referring to would you say like every single animal experiences the world completely differently? Because sometimes people would say like, oh, my dog's looking at me exactly how I'm looking at it, and it sees me exactly how I'm seeing it. But it's not the case, obviously.
Absolutely. We have to allow that there could be consciousnesses out there that we're completely unaware of. In fact, infinitely many of them with conscious experiences that we might not even be able to concretely imagine. So if I ask you to imagine a specific color that you've never seen before, does anything happen? I mean, for me, nothing happens. I just, smoke comes out my ears, but nothing happens in terms of seeing a real color. If I can't even concretely imagine one new color, what that shows us is that our perceptual systems are, in some sense, our window on the world. They're also an ironclad prison. I can't think of a specific color outside of the prison that I've been given. So it's very interesting. Our visualization tool limits what we can perceive, but we could certainly imagine abstractly that, for example, a colorblind man can't see the red greens that the rest of us can see. But they would be foolish to say, well, because I can't imagine them, they don't exist, right? We'd have to tell this colorblind man that, look, you can't see these colors, you can't even concretely imagine them, but I assure you, we have these color experiences. And I'm saying the same has to be true for infinitely many conscious agents out there, that they have an infinite variety of conscious experiences that we can only abstractly imagine. We can't concretely imagine any of them. And so the theory certainly makes that a clear proposal. And it's a mathematically precise proposal. So my colleagues can now try to take it down with the scientific method.
You're saying that we live in a interface through our eyes and our vision. Would you say that everything is a simulation? Like we don't actually exist when we're in a computer program, or just our eyes are seen as a computer program?
Right. So I would say that, for example, there's a separate hypothesis, the simulation hypothesis that Nick Bostrom and others are proposing. This is all one big computer simulation, so that there's some base world in which some geeky programmer is playing around and booted up a new world of programmers and playing with them. And those programmers themselves could be themselves writing software and booting up another. And who knows where we are? We could be level 50 or something like that. So we're just a simulation. And I'm saying something a little bit different. Nick Bostrom and most of the people who are doing the simulation theory believe that at the base level, it's just a physical realm, that the fundamental ingredients at the base level are unconscious. And so they still have the problem, how can an unconscious foundation boot up consciousness? So if for simulation theory of that kind to work, they still have to solve the old hard problem of how unconscious ingredients can be used to cook up consciousness. If they can do that, then great, then simulation theory might be a viable alternative. But just to say that we're writing programs and as a result, the artificial intelligences are also conscious, that there's work to be done there. I mean, artificial intelligence is fine because intelligence is a functional property. So I can imagine a computer has genuine intelligence in the sense that it behaves adaptively in various situations. That's very different than actually having conscious experiences. So I'm fine with computational models of learning, memory, problem solving, intelligence, planning, and so forth. All of that perfectly fine. Computational models are just fine because those are all functionally defined properties of the mind. It's only experiences that escape that. Just the simple thing of the taste of chocolate, that is where all the tough, hard problem comes from, not intelligence. So the simulation theorists, I don't doubt that they can model intelligence, learning, memory, problem solving, all that. No doubt that they can model that. We can do that. What I'm saying is they can't, if they're going to start with unconscious ingredients at the base level, then they have to explain how they boot up consciousness, the taste of chocolate. And I claim that they just can't do that. But in a more general sense, I mean, this is in some sense a simulation. So not in the Nick Bostrom sense, but in the sense that this is a visualization tool. It's a virtual reality that we're creating as a way of dealing with the complexity of that vast social network, right? So I don't want to see all the Twitter details or the Facebook, all that social network. It's just too complicated. I'd like this simple three-dimensional graphical tool that lets me see that in a way that I could. By the way, if we really understand how, suppose this idea is right, and our perceptions of space and time really are a visualization tool for social networks. Once we understand how our tool works, we should be able to use that to help us build good visualization tools for Twitter and Facebook and so forth. In other words, we should reverse engineer what's actually built into us, and that will be the most easy tool for us to use for visualizing other social networks. So this actually has a practical, if I'm right, this has a practical application. We need to really reverse engineer how this visualization tool is used to represent the realm of conscious agents I'm talking about, and then use that for Twitter, Facebook, and Snapchat and all the other social networks. So now about space itself, our perceptions of space are very, very interesting. If I look at a mountain like in Irvine, we have Saddleback Mountain, which is not too far away. And if I see the moon rising behind Saddleback, which it often does from my perspective, the moon and Saddleback Mountain look about the same distance. Just to of course, I know that the moon is 250,000 miles away and Saddleback is just a few miles away. But to my eye, it looks like, well, the moon is almost touching Saddleback. So what's going on there? Well, evolution, by natural selection, has given us a graphical interface. We don't need to see all the distances out to billions of light years or even 250,000 miles. We only need to see distances for a small range. And pretty much distance must be a coding evolutionarily for the caloric costs to me to get the resource over there. So space is not the objective reality, it's a data structure. It's telling me how much of my energy I'll have to spend to get that apple over there. If I see it as further away, what it's really saying, it's a fitness cost to me. It's saying you're going to pay more fitness costs to go over and get that apple. So it allows me to prioritize how I'm going to spend my energy. Do I want to try to get that apple that's 3 miles away or the apple that's only 3 inches away? Well, it might be wiser to only use smaller calories and get the one that's 3 inches away. So we think of space as the objective reality that we live in. No, it's just a data structure that we use. And one of its purposes, probably not the only purpose, but at least one of them, is to tell us the caloric costs. What percentage of my energy reserves will I use if I try to get that resource versus this resource? So in some sense, when I see Saddleback and the moon as just far away, what my coding system from evolution is telling me, that's essentially infinity. You really don't want to try to go to Saddleback to get that apple because that's effectively probably going to use all of your caloric. So that would run your battery dry. So that's infinity. So the moon and Saddleback are an infinity because you would eat most of your resources to get there. So when we actually go into space, what's really happening is So we have this little bubble of our visualization tool, right? My bubble only stretches out a few miles effectively because the Saddleback and Moon are about the same. But as I move, what I view as myself moving through space, what I'm really doing is I'm moving through this through this network of conscious agents. So I'm moving through that, and what I find is as I do that, my bubble keeps going in front of me. So I can sort of keep doing that and say, well, I could actually do that out to like 13 billion, 14 billion light years. So, but it's not like I see 13 or 14 billion light years. I just realized that as I use my graphical tool to go through this social network of conscious agents, I could keep doing it. And according to my own little scale, it would be 14 billion light years or something like that. So that's what we're doing in physics. We're taking our little bubble, our little user interface, and we're extending it by what mathematicians call a group action. It's a group action that allows me to extend that. So we can get at what we call the scientific worldview by taking our local visualization tool and seeing how it applies as we move all through this network of conscious agents.
What's your take on, I don't know if I'm even using the right phrase, but like dark matter and dark energy and how that fits into your theory? With kind of like if your theory becomes more, I guess, like realized, I don't know the right word for it, like would it kind of be able to allow people to kind of like understand what dark matter and dark energy is?
Yes, in fact, what's interesting about this approach, it says that our perception of space-time and objects is not a perception of reality. It's just a user interface that tells us what we need to stay alive. Anything that we don't need is going to be omitted from the interface, right? Because every calorie that you spend on perception is a calorie that you have to go out, kill something, and eat it to get that calorie. So there are selection pressures for us to do things on the cheap. So if you don't absolutely need it to stay alive long enough to reproduce, you're probably not going to see it. There's going to be strong selection pressures for us to be ignorant about everything that doesn't kill us before we reproduce. Now, if something will eventually kill you, but only when you're a grandpa, then evolution goes, okay, we'll let it kill him. Right, because
Probably
you've
have time to
reproduced.
reproduce already.
Yeah, you've already reproduced. So that's why we get cancers and so forth
I see,
more
gotcha.
as we get older. All the mechanisms in our bodies are designed just to keep us alive long enough to reproduce. There's no selection pressures once you've gone past that. So yeah, too bad. But this means that there are no selection pressures to see all of the truth. So I would predict that almost all of reality is not seen by us in our interface. Our interface hides most of the reality. So we used to think, a few decades ago, that we saw all of the truth. I mean, space time, protons, neutrons, quarks, and so forth. This is all of reality. Now we're down to 4%, 4 or 5%. With dark energy and dark matter, we realize, okay, the stuff that we know about is only 4%. I wouldn't be surprised as we learn more, we'll realize, okay, no, now it's only 1%. Now it's 0.5%. So in other words,
Now it's like 100%.
yeah, that's right. So I think the trend is going to go that direction. So I'm not surprised about dark energy and dark matter. It falls right out of the prediction of this theory that we weren't shaped by our graphical visualization tool is only telling us aspects about the social network of conscious agents that we need, but not the ones that we don't need. And the parts of the network that really aren't really affecting my own fitness aren't being shown to me at all. So dark energy falls right out of this. I mean, not the details of dark. Well, there are no details of dark energy. There is no theory of dark energy right now. So there are no details to.
So if everything's an interface, what about like new ideas and new technologies? Where would those come from? Since we've never seen them before, but people create them, how do we perceive them as what they are?
Right. So from an evolutionary point of view, so I'll put on the evolution of natural selection. We've been shaped by evolution to have a certain range of perceptions, but with strong limits. Like we saw, we can't think of a concrete color. We also have a range of concepts that are available to us that are useful tools. And the concepts that are available to us are very different than, say, the concepts available to a monkey, right? I wouldn't try to teach quantum mechanics to a monkey. Doesn't matter how long I try and how good a teacher I am, the monkey's not going to get it. They don't have the concepts needed. So we will have, from an evolutionary point of view, we'll have certain concepts for our species that are accessible to us. And within that realm, we can combine and try different ideas from those concepts and discover new things. But we have to expect that there are hard limits to what we can do. Some people actually take that attitude and say that's why we can't solve the hard problem of consciousness, right? So some will say, well, conscious experiences really do get caused by the brain. So they say, the brain really does cause our conscious experiences. The reason we don't have a science of that is because we don't have the concepts needed. This problem is as hard for us as quantum mechanics would be for a monkey. A monkey doesn't have the concepts for the quantum mechanics. We don't have the concepts needed for the hard problem of consciousness. That's an interesting point of view. I can't rule it out. We don't have access to all concepts, and there are some people who have concepts that I find very, very difficult. Anybody who's taken a class in calculus experiences firsthand how there are concepts that other people have had that might be difficult for me to understand, right? So
How's funding for this theory? Is it like becoming more popular? Because I remember we spoke about it like maybe surprisingly 10 years ago since I took your class, so time kind of tends to fly. Has it become kind of more popular in mainstream science to kind of get more funding for what you're trying to research?
funding for an idea in which consciousness is fundamental is very, very difficult, right?
Really?
That's very, very difficult. Most of the funding is studying the neural correlates of consciousness, those understanding the brain activities that are correlated with conscious experiences. And the assumption among cognitive neuroscientists is still that brain activity causes conscious experiences. So I'm fortunate. I have a funder, a gentleman named Federico Fagin, who is very, very farsighted and thinks that research into consciousness is really important. And he understands that standard funding by the NSF and NIH and so forth, I mean, they're happy to fund consciousness research in the federal agencies, but it's one that's neuroscience based. That it's trying to figure out how neuroscience creates consciousness. That research has to be done. I'm all for it. So I'm not opposed to neuroscience research. In fact, I think we need more neuroscience research. But for those of us who want to actually say, let's get a mathematical model of consciousness on its own terms and show how consciousness could boot up space-time matter and neurobiology. So consciousness is fundamental. Neurobiology is just a iconic description of consciousness. It's my interface description of consciousness. There's not much funding for that, but Federico Fagin and the Fagin Foundation has very kindly, for the last 4 or 5 years, funded my research at a level that allows me to continue.
Isn't it like accurate to say like, oh, if you just figure out like how consciousness is formed and how reality is more accurately perceived, it would give you a lot better technology, so it would give like the technology sector a huge boost because now you actually have like more accurate representation of what reality is instead of kind of like the limits you're describing and how science operates within those limits.
I absolutely agree, Eugene. I think that that's been shown time and again in science, that a new technology that really is giving us new insights into the nature of, as it happens, our interface, has always paid off with new technological advances that really change our lives. And it can really, and I think that this interface theory of perception that I'm talking about and the idea of conscious agents, once it's worked out, I think will lead to all sorts of new technologies that we can't even imagine right now. When Michael Faraday, the British scientist in the 19th century, was playing with electricity and magnetism and frog legs and making them twitch and magnets and so forth, it might have been really hard to imagine, what's this guy doing? He's playing with iron filings and magnets and little wires and so forth. He's just playing around. He did that. He really studied it. And then James Clerk Maxwell looked at what Faraday had discovered in terms of just what happens. And Maxwell, who was a mathematical stud, was able to write down what are called Maxwell's equations about how electricity and magnetism work. And all of a sudden, bam, that was very, very powerful. Because of Maxwell's equations, within a few decades, we had electric lights. We had an electric grid going up. We understood how electricity and magnetism worked. So what was playing around with iron filings and magnets and so forth in the middle of the 19th century, by the early 20th century, it transformed us. And by the way, it was Maxwell's equations that Einstein was studying when he discovered special relativity. So, I mean, you never know. So now special relativity led to E equals mc squared. It led to nuclear power. So, I mean, you just never know where this is going to go. So I think, and by the way, the nuclear power example makes it clear that this can be both for good or for bad, right? Scientific knowledge gives us, it's like Pandora's box. It can be very, very good or very, very dangerous. And it's both. It just depends on how human nature decides to use it.
Do you feel like within your lifetime there'll be huge breakthroughs in this field, or do you feel it's like going to have to be taken up by the next generation of scientists and the next generation, maybe a couple of generations later, then bam, like Dr. Hoffman was at the source of it, but someone else kind of really kind of hit it big.
I'm hoping it's in my lifetime, and I teach the class on the mind-body problem that you took and so
Uh-huh.
forth to hopefully inspire a new generation. And I'm starting to do lots of videos and podcasts now, like, to get a next generation of thinkers that are technically sophisticated, that have mathematical tools, neuroscience tools, programming tools to think in this way. The new generation, I think, can think out of the box. They can actually take these ideas and run with them in directions that will surprise me. I'm hoping it's in my lifetime. I'm working out to try to make it in my lifetime. I'm eating healthy and working out and trying to take care of myself. I'd love to stick around to see what happens. But I have interesting hints that there might be some good connections. I'll just, it's a little technical, but I'll just mention it briefly. I mentioned that Nima Arkani Hamed and the physicists who are working with him that have discovered that space-time is doomed and there's something simpler and deeper that's outside of space and time. And that it has to do with just simple permutations. As I mentioned, 1, 2, 3, 3, 2, 1, 1, 1, 3, 2, and that somehow the dynamics is the permutational dynamics, and then it's somehow amplified up into this what he calls an amplitude-hedron, a geometric thing, and then that gives rise to the properties that we call space-time. But although he has no idea what that realm is about, what is the world that's deeper that has this permutation dynamics? Well, to my surprise, theory that I'm working on with conscious agents, this is a little bit technical. The dynamics is, as I wrote it down years ago, is based on something called Markovian kernels. And Markovian kernels are these, if you know matrices, they're matrices in which each row sums to one. They tell you if the state of the world is this, then the probability that my action might be this is, and it gives you the probabilities. And it's just a list of all these probabilities. When you write that down, it's called a mark. Anyway, it's sort of technical, but what I found is that when you look at the long-term behavior of these conscious agents, what they call the asymptotic, what happens when you look at them for not just a few minutes, but hundreds of years or long, long, long time, it turns out that all the dynamics, the asymptotic dynamics, becomes permutations. All the complexity gets reduced to a much simpler kind of dynamics. It's just permutations. Well, that's pretty interesting because what Nemo has found is that the foundation of his framework, where he has no idea what it's about, it's all about permutations. Well, I have a framework that says there's this rich social network of conscious agents, but if you don't look at all the details of it, if you sort of data compress it by looking only at the long-term behavior, that can be described by permutations. So what I'm playing with right now is the idea is that this vast social network of conscious agents, when you data compress it, when you simplify it by looking at the asymptotic behavior, that's giving us the permutations that Nima and his crew are finding at the foundation of their booting up of physics. So if that's right, that already is an incredibly powerful link, and I want to pursue that because that could open this whole thing wide open. So it might be several generations, or if that link is correct, we could blow it open within a few years.
So like personal question, you're dealing with like these deep problems you never really hear on the news or anything. How do you kind of walk around on the street normally, kind of see like the everyday problems people are dealing with? And I'm like, man, or kind of think to yourself, like, man, this is what's humanity really has to figure out, not kind of waste their time like squandering over these issues that you constantly like see on the news or wars over this and that.
Right.
Like, how do you kind of like deal with that?
The interface theory, which says we don't see reality as it is, this is just a graphical tool. It is slowly changing how I see the world, right? I'm like everybody else. I just assume I'm saying the truth. This is the truth. I'm embedded in the truth. But now after several decades, and it's really slow. So I really understand how much this has a grip on the human mind, has a huge grip on my everyday life. I just assumed that this is the truth. But now all of a sudden, I'm starting to feel like I'm walking around with a virtual reality headset. This is just a virtual reality headset. I'm starting to actually enter into that. So if I go too far now, I may need some psychological help. We'll see. But then in terms of the everyday things that humans do, there's another aspect to that I think is really interesting. There's a field called evolutionary psychology. And it's a wonderful new field. It's been in the last 40 or 50 years that it's really taken off. And that field is our best scientific understanding of human nature. Why do we have the emotions that we have? What's the logic of it? Why are we altruistic sometimes? Why do we fight other times? Why do we have feelings of guilt? Why do we want to get retribution? Why do we want to get revenge? It turns out evolution, by natural selection, in particular, evolutionary psychology, gives us very, very deep insights into these aspects of human nature. I highly recommend, by the way, Steven Pinker's book, How the Mind Works, and also The Better Angels of Our Nature. Wonderful books, finalists for the Pulitzer Prize, well-written books. They really give the best understanding that we have in science about the whole panoply of human emotions and the deep logic that really, there is a deep logic to our emotions, including a deep logic about why sometimes we have conflicting emotions, why I can both love my brother and hate him at the same time. How is that possible? Evolution gives the logic of even conflicting emotions. So when I look at politics and society and so forth, the way I look at it is influenced not just by my own interface theory and the conscious agent network theory, but by the only real science that we have right now of human nature, which is evolutionary psychology. And one thing that does for me is at first it gives me a lot of insights when I can see people's behavior and I can just understand what's going on there. It's a very, very powerful tool. So I highly recommend it. It's really a useful tool just for everyday life to understand why people are doing what they're doing, evolutionary psychology. But it also has made me far less judgmental. I began to realize the assumptions that I used to make, well, you shouldn't do that, and you should know better. Well, it's more complicated than that. It's just more complicated than that. And of course, if someone is a sociopath and hurting people, we need to do things to make sure that they don't hurt people. But on the other hand, my knee-jerk reaction that I used to have to say, well, I was a horrible person and you should do better. I don't have that anymore because I have a deeper understanding of what's going on there. We actually know that there are genes that are involved that code for that kinds of behavior, and there's an evolutionary logic that actually keeps those genes in the gene pool. Women are actually, if you're in a war zone where men are fighting, women are automatically more attracted to men who have these sociopathic kinds of genes, where they're more hard-hearted, their cruelty doesn't bother them as much, they're willing to do nasty stuff. Women find them more attractive because those are the guys, not Hoffman, that are going to protect them when stuff is going down, right? I'm not going to, I'm the pansy. I'm not going to. Whereas the sociopath is just to, and women are automatically attracted. So all of a sudden now, from this deeper point of view, it's like, okay, in Irvine, I'm fine. I'm a good guy in Irvine. In a war zone, maybe I'm not the person that a woman needs to be around. I mean, maybe she needs to get the big buff not just buff, but sociopathic guy, right? And so when you start to look at these things more deeply and across species, so for example, fratricide is clearly wrong among humans. Killing your brother or killing your sister, siblicide, is wrong for us. But there's a bird called the blue-footed booby. The mother always lays 2 eggs. The 2 chicks hatch, and the first thing they do is they fight each other to the death. One wins. It either pecks the other sibling to death or pecks it and puts it out in the sun and it bakes to death. And the mother's sitting there watching this and does nothing to stop it. She killed her sibling. That's why she's there. And so you go, cool, that's horrific. That's ugly. It's nasty. But it turns out in their niche, the blue-footed booby does not have enough resources in general to successfully raise 2 chicks. So that species is faced with a choice between siblicide and extinction. And so for that species, the solution is siblicide. You have two offspring and let the stronger one win. That way you keep the stronger genes passing on to the next generation. Now, that's obviously not the way we want humans to be living, but this now forces us. This is what's happening in nature. So it forces me to say all of the assumptions that I have about right and wrong and morality and so forth, I need to think about them in a bigger context. And we don't have that context yet. I mean, I don't have myself a theory of morality that I'm comfortable with. But I do know that the theory of morality that I grew up with is far too parochial. And so in the meantime, of course, I'm going to behave properly and treat people well and take the parochial as the working hypothesis. But as a scientist, I want to dig deeper. I want to understand, is there a deeper notion of right and wrong and morality that would apply not just to Homo sapiens, but to all species? What is that deeper theory? I don't have it. I'm very interested to see it, but we have to look without flinching at everything that happens in nature. Now, of course, from my point of view, that's just an interface, right? So everything I'm seeing is just an interface. I have to try to reverse engineer and ask, what is that telling me about this network of conscious agents? Because ultimately, my theory of morality is going to be something about how conscious agents interact with each other. And I'm just getting a reflection of that in my graphical visualization tool. So I've got a lot of work to do, but I'm going to want to have a much deeper theory of morality. What is the morality that is there a universal morality for the dynamics of conscious agents that then looks like siblicide is fine for the blue-footed booby, but it's not fine for Homo sapiens. That's you can see there's a lot of work to be done here. For me, the bottom line is the simple assumption that, of course, I know what's right and wrong. I know what morality is. Maybe it's much more complicated than we thought. And of course, we should take the best ideas we got so far and act and behave properly accordingly. But as scientists, we need to really dig deeper.
What if like Homo sapiens somehow continue to live for like another 200,000 years? I think they've been around for 200,000 years, right? But let's say like another 200,000 years. Do you feel like the brain will evolve in a way to simplify reality more and more, in the sense it would like dumb down more and more as time goes on? Or do you feel like the brain will evolve in like a better direction to allow, I guess, like the Homo sapien to see reality for more of what it is?
There's a surprising fact that has come from paleoanthropology, the study of our hominid ancestors and their fossils. For the last 20,000 years, our brains have been shrinking. Our ancestors 20,000 years ago had 10% more brain volume than we have. We've lost the volume of a tennis ball in only 20,000 years. Huge. It's stunning. So our species took the escalator up in brain volume. We're taking the elevator down. Our ancestors 20,000 years ago were also stronger. They were more robust than us. So if they came to saw us today, we would be stupid wimps. That's how they'd see us all as stupid wimps, except for you guys. They wouldn't see you that way, but they'd see me that way. And so the question is why? Why are our brains shrinking? Well, the answer is not sure, but one interesting hypothesis is we transitioned about that time from being just hunter-gatherers to starting to have agriculture. We started to actually plant and grow crops. And that required a social network, because now you have to be in one place, you have to stay with the crops, you need to protect the crops. Because what happens when you're hunter-gatherer? Well, you just find whatever's out there and you eat it and you move on. When you're growing crops, now you've got this valuable resource. You spent the better part of a year doing all your work to get this. It's very tempting for a marauding group to go, well, they worked for a whole year, we didn't, we'll just come in and take it. So now so if you're going to do that, you now have to have a society that not only does all the agriculture, you need to build walls, you need to have an army, because it's too tempting to take all this high value food. So we got a social structure. And what happens when you get that social structure is it takes some of the selection pressures off the individual. When you're out there on your own, or with a very, very small group, hunting and gathering, you got to make your own clothes, and you got to know how to do it. If you get cut, you have to know what to do to heal that cut. You have to get all of your own food. If you mess up at all, you die. The selection algorithm is extreme. It's not just a pass fail. It's like live die. It's really, really nasty. But with a social network, you have a social safety net. I can have an IQ of 70. I can go to Trader Joe's and be just fine today. But not 20,000 years ago, trying to be a hunter-gatherer, that probably wouldn't have worked. I would probably just get killed, eaten by a tiger, die because of stupidity. Because we were trying to.
Still happens today to a large
But
degree.
we still do. The social network can only go take you so. But since there's less selection pressures on each individual, there's then evolution tries to do things as cheaply as possible. It's a use it or lose it principle. If we don't need all those brain resources, well, the brain is a pig. It eats up 20% of your calories. It's only 3% of your body weight, but it's 20% of your calories. So let's squeeze that brain down a little bit. Let's make it smaller, fewer calories, because evolution does things on the cheap. So that seems to be what's happened for the last 20,000 years. It's been very, very rapid. And what they found, John Hawkes is one of the paleoanthropologists who's at the forefront of this. What they found is the brain volume declined most rapidly in areas where there was the biggest concentration of people, suggesting this social network theory, that the social safety net, I'm grateful for the social safety net. I'm surely one of the ones that would have been selected out, right? I wouldn't be here. Probably most of us wouldn't be here. So we can all be grateful that we evolved the social safety net and that we're here. But the price is we're probably a lot less bright than we were 20,000 years ago and a lot less robust. So who knows how that will continue? We do have to be sophisticated socially. So there are selection pressures for sophistication socially, whereas less selection pressures to be sophisticated in dealing with raw nature, right? In some sense, raw nature doesn't kill us as much, although maybe with climate change, it will start to do so again. But raw nature isn't the big enemy that it used to be. It's now other people that are our biggest competition. That changes up the dynamics about what parts of the brain might be emphasized as we evolve. So, but definitely the standard idea that, it's just all up. We're going to be evolving these bigger craniums. We'll look like aliens with big vaulted brain. That's not necessarily on the cards.
Gotcha.
I think we're actually probably getting shorter, because as I just picture, we're always looking up, like as cavemen, they're always looking up what's further, what's explorers, and now in today we're always looking down at our phones, and we're not always looking up to the sky, we're always looking down. So I feel like we're gonna shrink because our posture is so much worse now. And
the selection pressures, it turns out if you, for example, they find that if animals get stuck into a small island, they tend to shrink. You can get pygmy elephants and things like that. So if you're in a small area with smaller resources, your body tends to grow or shrink depending on the food supply that's available to you. So, but it's complicated. You're right. There's lots of things that could go into the whole process. With better nutrition, one can expect that we will reach potential for height. I'll just say one other thing, and that is spirituality. I mean, one might be interested in how this plays out in spirituality. And again, ultimately, I don't know, but what we do know is that people in various spiritual traditions have the notion of some kind of higher power, some kind of infinite consciousness of some kind. Some traditions might call it God or Brahman or Allah, exactly, Jehovah, things like that. But no one has ever said precisely what they mean by that, right? It's just bigger than us. It's an infinite consciousness, perhaps, of some kind. But religions have been around for thousands of years, and we don't have a precise idea what we're talking about. We all intuitively say, well, I think I know what you're talking about. And then some people are atheists and say, I maybe I know what you're talking about, but I don't believe it. But there's nothing concrete on the table. And my attitude is that the questions that the religions bring up, like, what kind of creatures are we? Why are we here? What is this all about? What is the meaning of life? Those are important questions. And science is the single best method that humans have discovered for trying to answer questions. Science is not a particular theory. Science isn't physics. It's not. Science is a method of inquiry of making precise proposals and making precise claims and then saying exactly how you could prove those claims wrong. What experiments could you do to prove those claims wrong? And having a dialogue along that line. I would like to have that kind of rigorous dialogue, the scientific method, applied to the very important questions that the spiritual traditions address. And I think that we can. Again, my theory of conscious agents is probably wrong, but it's precise. And one thing that comes out of this theory is it says when two conscious agents that are finite interact, they can create a new, more complicated conscious agent. Well, there's no limit to that. I can keep creating, I can go all the way to infinity. But I have mathematics. I can actually start to do theorems and proofs about the nature of an infinite consciousness. It's no longer just, well, it's beyond me. No, not at all. I can actually talk about how many of them are there, what's the relationship between infinite consciousnesses and finite consciousness. We can actually start to address this kind of thing. Now, again, I'm probably wrong, but that's not the point. I'm precise. For the first time, we can begin the scientific process of saying, okay, here's where you're wrong, and now let's try to fix it. But until we get something rigorous on the table, we can't actually get into, we're not even wrong yet, right? The point is to be precise enough so that you can be wrong. The spiritual traditions, in many cases, just aren't even wrong yet. They're not precise enough to be wrong. And what we'd like to do is to get precise enough so that we can be wrong. But the attitude that's required here is one of humility. It's not, I know the truth, my spiritual tradition is absolutely right, and you're wrong. Which I don't think the deepest believers in most traditions don't say that. Right? But a lot of the other people do. I mean, but having an attitude in which we have a respect for all the different spiritual traditions. Not that we say that we believe them, but we respect them. We try to get as many good ideas from each tradition as we can, and then have a respectful dialogue where we say, okay, now let's ask precisely what does that mean? Precisely. And try ultimately to get mathematical precision so that we can then say, okay, what experiment could we do to see if that idea is right or wrong? And then we can start to make progress in terms of getting real answers to the biggest questions. Who are we? Why are we here? What is this all about? And I think all of us want to get to those answers. And I think that believing that I know the answer, believing that my tradition is right, gets in the way of honest inquiry. I think that if you believe something and in some sense you say, I know that this is right, so I don't need to look further. I mean, why should I look further? I already know I'm right. I know it's hard in the spiritual traditions to do that, but if we can let that go a little bit and just say, okay, these are the ideas that I think are interesting ideas, but maybe I'm wrong. Maybe this is wrong. That's not blasphemy, it's honesty. Let's just be open and say humbly, maybe we're wrong, maybe we're right. Let's have the humility to explore these ideas and see where they lead. And maybe, Buddhism and Islam and Christianity and Judaism and all these other, shamanism, there'll be little nuggets from each one and maybe lots of nonsense. Who knows? We try to get the nuggets and piece together the puzzle of who we are and why we're here. And I think the scientific method is a powerful tool for doing that. And it's not that scientists are in some sense superior. It's just scientists are just as dogmatic. They're human beings like anybody else. It's the scientific method which says, be precise and tell us how we could show you to be wrong. That's sort of at the heart of science. Bringing that to spiritual, I think, would be really a big step forward for humanity. It's going to be hard though, because we all deeply want, many traditions, a lot of people, what I have been taught, of course, is the truth. And in fact, if you don't believe it, yeah, you're going to hell or something like that. If we can sort of back away and say, well, if what I believe is true, then we should be able to test it. So let's try to find out if we can do real tests to see what's right and what's wrong, and let's be willing to admit if we're wrong, and willing to admit if some other tradition has an insight that we didn't have that might actually help us. After all, it's not so much, my attitude is not so much to prove that I'm right and you're wrong. It's rather, hey, none of us really know. I would like to hear what you're saying. Maybe you'd like to hear what I'm saying. And we might not agree, but at least if we exchange ideas, we might learn something in the process. So I think there's something about spirituality that I'd love to see going forward as well from this whole.
Where can people find out more about you?
Okay, a good question. So I have a website. If you just Google Donald Hoffman, Hoffman, my homepage is there. So it has links to all of my videos and podcasts and papers. If you want to look at my scientific papers, they're all listed there. Most of them have links to free online sources. So I've got 100 and plus publications. So if you want to dig into the experiments and the math behind this, I've got a new book coming out in August.
Oh, wow.
And it's already available on Amazon. So you can.
I already pre-ordered my
You pre-ordered
copy,
it?
two of them.
Yeah, it's called.
Hopefully
Thank
it's
you. Thank you
Amazon
very much.
#1 bestseller.
Hopefully, yes. Hopefully. It's called The Case Against Reality. The Case Against Reality. And then the subtitle is Why Evolution Hid the Truth from Our Eyes. And it's for a broad audience. So I'm not talking just to scientists. I'm really talking, I would say, to lower division undergraduates. I'm trying to make the ideas accessible to a broad audience. So I have no math in the book. I have a little mathematical appendix that no one has to read.
Perfect.
All right, perfect.
What is one interesting fact about yourself?
My father was a Protestant minister, fundamentalist Protestant minister. So when I talk about the spirituality stuff, I know firsthand what it's like to be within that tradition and to experience it. And it's taken, so I saw that. And, in some sense, I've been stepping back and asking, okay, what are the good parts to take from that? And what parts do I want to discard? So that's sort of what I talked about spirituality. I mean, I had a firsthand immersion in one spiritual tradition. So, yeah.
Very cool. Cool. Perfect. That's it for today. And thank you so much for coming as our guest on our podcast.
Thank you so much. I appreciate it.
Awesome.
Cool. Well, it was great to see you again. It's been, honestly, I think like 10 years since we last met. So
Great to see you again.
yeah, it's good to see you. And thanks for being on our podcast.
My pleasure. Thank you for having me.
If you like our content and you want to have more of it, send us an email. It'll be in the show notes, and tell us what you want to hear about.
If you want the most recent updates from us and you enjoyed this show, please subscribe.